To watch these important lessons, subscribe to DP Education's YouTube channel right now. Click on the bell icon to stay updated on the latest lessons. Sri Lanka's largest free online school, DP Education.
Hello my dear students, welcome to today's lesson. So I am going to continue with the extra questions related to household electric circuits or domestic electric circuit. So in the lesson you can remember we discussed power, energy of electric appliances, then the efficiency of electric appliances, the components of the household electric circuits and the commercial unit used to measure electricity consumed by the consumer. So that was for the lesson. And then we discussed the questions given in your textbook, and in the previous chapters also I discussed extra questions with you. So now I am going to continue extra question 13. 1. What is the difference between the trip switch and normal switch when turning them on? So normal switch, you press the lever down. So you all know when you press the lever down, switch on means press the lever down, that is the on position. But for a trip switch, when you move the lever up, push the lever up only, the trip switch becomes switched on. When you pull the lever down, it is off position. So it is the opposite in function when switching on and off the normal switch and a trip switch. So here they have asked, what is the difference between the trip switch and normal switch when turning them on? So here we can say a normal switch is turned on by pressing, or you can say moving the switch down. But the trip switch is turned on by moving the lever upwards. So here you can say moving the lever upwards or pushing the lever upwards. That is the difference. A normal switch is turned on by pressing the switch down. This is how you switch it on. But in a trip switch, you have to move the lever up. So that is the difference between a normal switch and a trip switch. I am sure you can remember that. So with that students, we'll move on to the next question. Extra question 14. Arrange the following components in the order they are connected to the household electric circuit. So electricity meter, trip switch, isolator and overload circuit breaker. If you recall all the components, initially from the distribution subcenters, electricity is supplied by electricity distribution wires. So from the distribution wires, electricity passes on to the supply cable. The supply cable is connected to the overload circuit breaker or the service fuse. Then it is the electricity meter, and thereafter you get the isolator, and after that it is the trip switch or the RCCB, residual current circuit breaker. From there, electricity is supplied to the distribution box. That is the order of components. So here if we write them in order, first we have the overload circuit breaker, Then we will have the electricity meter, Then we have the isolator and then the trip switch. isolate and trip switch. That is the order. Overload circuit breaker, electricity meter, isolator and trip switch. Then the next question. What are the two wires present in the service cable that supplies electricity to the household? So, in the service cable, what are the service cable or the supply cable? What are the wires? The live wire and the neutral wire. So, it is the live wire and neutral wire. Live wire and neutral wire. So then students, the third part of the question, to what wire is the isolator connected? So you all know what the isolator is. It is the main switch with the main fuse. Now you all know isolator is capable of disconnecting both live and neutral wires. That is why we call it a dual pole switch. But from the electricity meter, now you all know the component students. Initially we have the overload circuit breaker. There it is only connected to the live wire. Overload circuit breaker disconnects only the live wire. Then the live wire is connected to the electricity meter. From the electricity meter, the live wire connection is given to the isolator. But isolator can disconnect both live and neutral wires. That means to what wire is the isolator connected? It is connected to both live and neutral wires. If it's not connected to both, then it cannot disconnect both. No. So, because the isolator is connected to both live and neutral wires, it can disconnect both live and neutral wires. That is why we call it a dual pole switch. You can remember that. So, here the answer to this question, to what wire is the isolator connected? Live wire and neutral wire. So, it is connected to both the wires. I am sure you all can understand that. So, we have answered these three questions, students. Here you all know both live and neutral wires are present in the service cable that supplies electricity to the household. Then, like I told you all now, the overload circuit breaker is connected to the live wire. Then, the live wire connection is given to the electricity meter. And from the electricity meter, the live wire is connected to the isolator. But at the same time, isolator is connected to the neutral wire also. From the electricity meter, it is only the live wire. But the isolator is connected to both live and neutral wires. That is why it can disconnect both the live and neutral wires at the same time. And it disconnects the power supply to the household. So, that is something you all have to remember, students. So, with that, I'll move on to the next question. Extra question 50. First one, write the colors of the cover used to identify the following wires. So, you all know the conducting wire is usually made up of copper, and around that there is an insulator cover. Usually it can be a rubber cover, a plastic cover, PVC cover, but that PVC cover has a color that is used to identify the different types of wires. So, you all can remember that. Now, live wire is brown in color, neutral wire blue, and the earth wire it is green. Earlier you all can remember, students, the live wire was red in color and the neutral wire was black in color. But nowadays, the wires, live wire is brown, neutral blue and earth wire green. You have to remember that. So, here, write the colors of the cover used to identify the following wires: live, brown, then neutral, blue, and earth, green. So, you can remember that. Then, the second part of the question. How are the bulbs and plugs connected to a domestic electric circuit? You all know how they are connected. They are connected in a parallel manner so that you can operate each of the bulb and the electrical appliance separately. And also I have explained about the potential difference. But here the main thing you have to remember, students, if you connect them serially, if there is a problem with one of the bulbs, then of course electricity will not flow through any of the bulbs. So there you can't operate them individually. Everything has to be operated simultaneously. So when you have them in a parallel manner, they can all be operated individually. So how are the bulbs and plugs connected to a domestic electric circuit? They are connected in a parallel manner. So they are connected in a parallel circuit, or we can say parallel manner. And you can remember, students, sometimes the plugs are connected in a ring or loop circuit. That is not always. Always they are connected in a parallel manner, both bulbs and plugs. But sometimes the plug circuits are connected in a loop circuit or a ring circuit. You can remember that. So then we'll move on to the next question. That is the third one. What is the maximum current that can flow through the cables connected to the following? So here plug circuit and lamp circuit. When we say plug circuit, you all know the maximum current that can flow through that is 13 amperes. Because the electrical appliances, they need to use more current. So the MCB connected to that is for 13 ampere MCB. So the maximum current that can flow through a plug circuit is 13 amperes. And through the lamp circuit or the lighting circuit, for the bulbs it is 6 amperes. You can remember that. For the bulb circuit or the lamp circuit or lighting circuit, it is 6 amperes. Is that clear, student? So if we quickly look at the questions, I'm sure you have answered all of them. The different colors for different wires, light brown, neutral blue and earth green. And also all the plugs and bulbs are usually connected in a parallel manner in the household circuit. And in the plug circuit, maximum current is 13 amperes. And the lamp circuit or the lighting circuit, it is 6 amperes. And you all can remember, students, to the lighting circuit, we can connect 2 plug sockets with a maximum current of 6 amperes. But to the plug circuit, you can only connect plug sockets where the maximum current is 13 amperes. You have to remember that. So with that, students, I'll move on to the next question. Extra question 16. Identify the 3 pins that will be inserted into the plug socket shown below. So you can remember we put the plug like this. So you know the wires on that are relevant to the different pins. Normally the large pin is the earth pin. Then on to your right side, when you look at the plug socket, your right side it will be the live wire and on the left side it is going to be the neutral wire. So when you look at it this way, you will be plugging in the plug top like this. So the earth pin will go into this, live pin will go into this and the neutral wire, the pin will go into the pin B. So there A is earth, then B is neutral and C is live. So identify the 3 pins that will be inserted into the plug socket shown below. Earth, pin connected to the earth wire, pin connected to the neutral wire and C, pin connected to the live wire. So we don't have to say pin connected to it because you know the wire connection will be the earth wire, neutral wire and live wire. Then the second question, what is the advantage of having pin A? What is the advantage of having pin A? If the electric appliance has a metal casing and if there is electricity leakage, that electricity will be earth, and at the same time the trip switch will disconnect the electricity supply to the household. So the consumer is protected from electrocution or electric shock. So here we can say if electricity leakage occurs to the metal casing, then it will make the RCCB, residual current circuit breaker, or the trip switch to disconnect the electricity supply to the whole household. Therefore, the consumer is protected from electric shock. So that is the advantage of having pin A. That is the earth pin. Any electricity that is leaking from the electrical appliance flows through the pin and through the earth wire. At the same time, there is electricity induced to the trip switch. Because of that, the trip switch disconnects the power supply to the whole household. Therefore, the consumer is protected from electrocution or electric shock. You have to know that. So that is the advantage of having pin A. So they gave us a diagram. You identified the different pins and then the advantage of having the earth pin. So with that, students, I will move on to the next question. Extra question 17. 15 ampere fuses were used in older domestic circuits. That is something you can remember. Now in the modern circuits, we have the miniature circuit breakers that use 13 ampere fuses for plug circuits and 6 ampere fuses for lamp circuit. But in the older households, instead of the miniature circuit breakers, there were fuses corresponding to 15 amperes. A higher current was allowed to pass through it. You know the fuse. Now fuse has a ceramic mount and on that there is a fuse wire connected. Depending on the maximum current that can flow through it, the diameter of the fuse wire varies. So when there is high current flowing through it, due to the heat generated, the fuse wire will burn off, and because of that, the electricity supply to that part of the household or the full household, if it is the main fuse, then will be disconnected. Then what we need to do is the consumer has to remove the fuse and he or she has to replace the fuse wire and then put the fuse back into the circuit so that you can get the electricity supply back. So that is how the fuses were used in the olden days. The first question. Why has the usage of fuses declined? So like I told you all students, when the fuse is burnt off, it has to be replaced. Now the fuse wire has to be replaced. That process is inconvenient. So because of that only, the uses of fuse has decreased. So that is what we have to write here. Because it is inconvenient to replace the burnt fuse wires. So because it is inconvenient to replace the burnt fuse wires, the usage of fuses has declined. We can complete the sentence. The usage of fuses has declined. So that is to complete the sentence. Even if you write, because it is inconvenient to replace the burnt fuse wires, it is more than enough. You give the answer, but here it is a complete sentence. Then, what is the component used instead of fuses in the modern domestic circuits? It is the circuit breaker. Overload circuit breaker as the service fuse. Inside the isolator, we have the main fuse. Then the miniature circuit breakers have the other, instead of the fuses, we use the miniature circuit breakers inside the distribution box. So it is the circuit breakers are used instead of fuses. So circuit breakers. So as examples, we can say overload circuit breaker, and miniature circuit breaker. That is MCB. So that is how we use the circuit breakers. Examples as well. Then the third one, to what wire is the fuse connected? We have answered a similar question before also. You can remember, to what wire? Always the fuse is connected to the live wire, because electricity flows into the electric appliance through the live wire. It flows out through the neutral wire. So always, if it is a high current, it has to be the live wire that has to have the fuse. To prevent damages due to high current, the fuse has to be connected to the live wire. So to what wire is the fuse connected? To the live wire. So the use of fuse decline because it is inconvenient to replace the burnt fuse wires. Then instead of fuses, now we use circuit breakers. Examples, overload circuit breaker, and miniature circuit breaker. Those are examples. Then to what wire is the fuse connected? That is to the live wire. So those are the answers, students. I am sure you all also wrote the correct answers. With that, I'll move on to the next question. Extra question 18. What is the component used to distribute electricity for the consumption in the household? In the household, to distribute electricity, we use the distribution box. Now you know the distribution box. There is a bus bar where all the live wires are connected to it, but from the bus bar, where before the live wire supplies electricity to the different appliances, there is a fuse. So that is the miniature circuit breaker, and then electricity is supplied to different parts of the household. That is by the distribution box. Electricity is distributed to different parts of the household. Then the second one. What are the components included in a consumer unit? You can remember that also. There are 3 components present in a consumer unit. The isolator, that is the main switch with the main fuse. Then RCCB, residual current circuit breaker or the trip switch. And the distribution box with the MCBs, miniature circuit breaker. So 3 components. So here, isolator, RCCB, residual current circuit breaker, or what we call as the trip switch. And distribution box. Distribution box with the MCBs. That is miniature current circuit breakers. So when you are writing the answer, students, you can simply say isolator, RCCB and distribution box. But for you all to remember and understand, recall what we have learned, I have given all the names: RCCB, residual current circuit breaker or trip switch, and then distribution box, it contains the MCBs, miniature current circuit breakers. Miniature current circuit breakers. So all these are contained in the consumer unit: isolator, RCCB and distribution box. So I am sure you all can remember that, student. So with that, I will move on to the next question. Then extra question 19. So first one, what is the component that records the electric energy consumptions of the household? What is the component? You can remember the electricity meter. It monitors and records the amount of electricity consumed by the consumer. So, electricity meter. Electricity meter. Then, the second one, what is the commercial unit of measuring the amount of electricity consumed? What is the commercial unit of measuring electricity? Kilowatt hour. Kilowatt hour, or you can write it as kW, kilowatt hour. You can write it in words, kilowatt hour or kWh, kilowatt hour. And the third part, what is the value of one unit you mentioned above in joules? Now you can remember, normally electric energy is measured in joules. But when we consume electricity for the household, the amount of electricity consumed, if given in joules, will be a very high value. That is why they have chosen kilowatt hours as the commercial unit. So now we will try to calculate. You are familiar with this calculation, how you convert 1 kilowatt hour to joules. What do you need to do? You need to convert kilowatts to watts and hour to second. Then you will get the energy in joules. So 1 kilowatt hour, that is equal to 1 into 1000 watts into 1 hour into 60, it becomes minutes, and into 60, then it becomes seconds. So here, of course, you will get the answer as 60 into 60 into 1000. So this is going to be in joules. 3,600,000 joules. Or we can write it as 3.6 into 10 to the power of 6 joules. That is joules equivalent to 1 kilowatt hour. That is the commercial unit. So you can see it's a very large value, 3,600,000 joules. So that amount is equal to 1 unit of electricity we consume. So that is why the commercial unit is being used as kilowatt hours. You have to remember that, student. So with that, I'll move on to the next question. You all are familiar with this calculation. Kilowatt hour, you need to convert to watts, and then you need to convert the time to seconds. So 1000 to convert to watts, 60 into 60 to convert hours to seconds. So you get the answer as 3.6 into 10 to the power of 6 joules. So then we'll move on to the next slide. Extra question 20. Write two components of the domestic electric circuit that protect the residents. Now, what are the components that protect the residence. You can remember one thing is the residual current circuit breaker RCCB or the trip switch that protects the residence from electric shock. Then the miniature circuit breakers, MCBs, they protect or they prevent fire caused to the electric circuit due to heated cables. They prevent that. So therefore, both the RCCB and the MCB protect the residents from different accidents related to electricity. So write two components of the domestic electric circuit that protect the residents. One, RCCB, that is residual current circuit breaker, or what we call as the trip switch. You can write any of the terms, students. You can say RCCB, or you can say trip switch, or you can even say residual current circuit breaker. Then the other one, MCB, miniature circuit breaker. Miniature circuit breaker. So that is the next one, miniature circuit breaker, MCB. Then the next question, briefly explain the protection provided by the components you mentioned above. So protection provided by the RCCB, residual current circuit breaker, it prevents or protects residents from electric shock. I have explained this so many times before to you all, students. If there is an electric appliance with a metal carrying or metal casing, and if there is electricity leakage to the casing, there is an earth wire connected to the metal casing, and through that electricity will flow. So one thing, it will get earth. At the same time, the electricity will be induced. Due to electromagnetic induction, there will be current flowing through the trip switch, and immediately, automatically, the trip switch will disconnect the electricity supply to the whole household. So because of that, it protects the residents from electric shock. But you all know it does not protect the residents from lightning. Although sometimes the trip switch can turn off or disconnect the electricity supply to the household, but it does not ensure protection against lightning. So it is only when there is electricity leakage or earthing of current, trip switch protects the residents from electric shock. That is how the RCCB protects the residents. So here we can say RCCB. So RCCB protects residents against electric shock or electricity leakage. Electricity leakage. So that is how RCCB protects the residents. Then the MCB. MCB does not protect the resident from electricity shock or electricity leakage, but instead it protects the residents from electric shorts. If there are electric shorts or overheated fire caused by overheated cable, that is prevented by the MCB, because you all know MCB connected to the lamp circuit, it allows the maximum current of 6 amperes. MCB connected to the plug circuit allows a maximum current of 13 amperes. If there is more current more than the maximum limit, then of course the cables will become hot because of the internal resistance. So therefore the cable can become overheated and that can result in fire. So that is prevented by the MCB. So we can say it provides protection against electric shorts and fire caused by overheated cables. So that is how these two components protects. So the two components are RCCB, residual current circuit breaker or trip switch, and MCB, miniature circuit breaker. Then here RCCB protects residents against electric shock or electricity leakage. Then MCB, it provides protection against electric shorts and fire caused by overheated cables. So you all have to understand how the protection is provided. So with that, students, I will move on to the next question. Extra question 21. Fuses protect the electric appliance from large currents. Write the maximum current that can flow through the components given below. So you all know fuses, they allow a maximum current to flow through it. If there is current more than the maximum limit, the fuse disconnects the electricity supply either to the household, if it is the service fuse or the main fuse, or else if it is the fuse in the MCB, only to that part of the household. So you all remember that. So then, service fuse, it is the overload circuit breaker. You can remember service fuse is present. It is the overload circuit breaker. What is the maximum current? You can remember it is 40 amperes. Then main switch with main fuse, what is it called? It is the isolator. And isolator allows a maximum of 30 ampere current. You can remember that. Then miniature circuit breakers used for the lamp circuit. What is the maximum current? 6 amperes. And miniature circuit breakers used for the plug circuit, maximum current is 13 amperes. So you have to remember all these. Service fuse or the overload circuit breaker contains the service fuse, maximum current 40 amperes. Main switch with main fuse, that is in the isolator, that allows maximum 30 ampere current. Miniature circuit breakers used for the lamp circuit, 6 ampere currents, and miniature circuit breakers used for the plug circuits, 13 ampere current. You have to remember that, student. So with that, I'll move on to the next question. Extra question 22. Select the correct precautionary methods from below and mark as correct. So if the precautionary method is correct, we put a correct mark, otherwise we'll put a wrong mark. First one, only fuses appropriate for 6 ampere and 13 ampere current should be used. That is correct. You can remember lamp circuit 6 ampere and plug circuit 13 ampere. That is a precautionary method. That is correct. Then, second one, any number of electric appliances that draw a total current exceeding the capacity of the plug socket can be connected to the plug socket through a multi-plug. Now, you all know the function of a multi-plug, students. You plug that into a plug socket and you will be able to use different types of plug tops. Say a 2-pin or a 3-pin, round pin, square pin, those can be plugged in. But you have to plug in only one electric appliance at a time. Because if you plug in more than one, then what will happen? For example, you'd say 2 electric appliances that need 8 amperes of current each. So when you plug in both, they will draw a total of 16 ampere current. That is more than the fuse. That is 13 ampere. So what can happen? If the fuse does not work properly, the cable can become overheated and due to that there can be a fire cost. So to prevent that, you should not use any number of electric appliances that draw a total current exceeding the capacity of the plug socket. So this is of course wrong. Here it says can be used. Then the third one. Any plug suitable can be inserted into a plug socket. Is it any plug suitable can be inserted? No. It is a plug that is suitable for that particular plug socket can be inserted into the plug socket. You can't just insert any plug. It has to be a plug that has that particular value. Maximum current has to be, let's say if it is 13 amperes, maximum current 13 amperes. That has to be connected into that socket. And also you all know students, normally if it is a 3-pin socket, it is usually advisable to plug in only the 3-pin plug, not the 2-pin plug. So like that you have to insert a plug that is relevant to that particular plug socket. So this is also wrong. Then the fourth one, wires should not be inserted into a plug socket. That is correct. You should never insert a wire into a plug socket. That is correct. Because wires, they can lead to many accidents. Then fifth one, no precaution is required when using an electric iron for ironing clothes. That is wrong. When you are ironing clothes, normally you can wear rubber slippers or you can put a rubber mat and stand on that and then you can iron the clothes. So you do have to take precautionary methods and also you have to make sure you are not using wet hands. So all those are precautionary methods. No precaution is required is wrong. And the sixth one, during a power failure, switches of electric appliances can be turned on. No, that is also wrong. If there is a power failure, you have to immediately turn off all the electric appliances. Then you need to wait until the power comes back or you get the power supply back or you have to try switching on the trip switch or the main switch and to check whether what the problem is. So when there is a power failure, immediately you have to switch off the electric appliances. So that is also wrong. Then the question continues on the next slide. We will move on to the next slide. Seventh one, tasks such as changing burnt bulbs in bathroom should not be done without turning off the overload circuit breaker or the main switch. So here students, you all can remember if you want to change the bulbs in the bathrooms. Now bathrooms normally there is moisture, water there. It is a place where you use water, so you have to be very careful. Therefore, it is always better to turn off the overload circuit breaker or the main switch before you change the bulb. So that is also correct. Then the eighth one. When electric appliances are not in use, their plugs should be disconnected from the socket. That is also correct. To prevent accidents, you should disconnect the plugs. Then, if there are strong lightning strikes, radio receivers and television sets need not be unplugged. That is of course wrong. You all know when there is lightning, you have to unplug the radio receivers and television sets in order to prevent lightning strikes. So this is wrong. Then the 10th one. In case of a fire, the domestic power supply should be disconnected using the overload circuit breaker. That is correct. You have to cut off the power supply to the whole household. The electricity supply to the whole household has to be disconnected. That can be done using the overload circuit breaker. So that is in case of fire. That is correct. 11th one, all maintenance work and installing power extensions can be done by any person. Is that correct? No. It has to be done by a trained electrician. An electrician who knows how to connect the wires and what to do. It has to be done by an electrician, not by any person. So, all maintenance work and installing power extension cannot be done by any person or can be done by electricians only. So, this is wrong. Then the last one. the functioning of the RCCB should be checked every few days by pressing the test button. That is correct. You have to make sure that the RCCB is working. Then only you will be protected against electric shocks or earthing of current. So that is also correct. So these are all different precautionary measures. Now that since we discussed all these, you all know what the precautionary measures are. So I am sure you were also able to tick them, mark them correctly. With that, students, I am going to move on to the next question. So extra question 23. The power of an electric motor in a home is 1000 watts. So you are familiar with these questions, students. 1000 watts is the power of the electric motor. This is used for 1 hour daily. Now here you can see it is used for 1 hour daily. And there are 240 watt bulbs are used for 2 hours daily. So two different types of electrical appliances. The electric motor has a power of 1000 watts and it is used for 1 hour daily. And there are 240 watt bulbs that are used for 2 hours daily. So let's look at the questions. Calculate the number of units used up by the electric motor in 1 day. In this question, students, they are asking only for the units used up by the electric motor in 1 day. So here, units used by electric motor. Or you can just write units also and do the calculation. So how do we calculate the units? Number of units is equal to kilowatt hours. You can remember that. So here the power is given as 1000 watts into time duration 1 hour daily. In order to convert this to kilowatt hours, we need to divide by 1000. So how many kilowatt hours? 1000 and 1000 gets cancelled off. So it's going to be 1 kilowatt hour. Or that is equal to 1 unit. 1 unit of electricity is consumed by the electric motor in 1 day. You have to remember that also. So that is 1 unit. Then, if we look at the second part of the question, calculate the number of units used up in 1 day. So there they say calculate the number of units used up in 1 day. That means by both the devices, the electric motor as well as the bulbs. So then what we can do is normally if we did not have this first part of the question, we need to write this equation as well as for the bulbs and add them together. But now since we have calculated the number of units for electric motor, we need to calculate the number of units for bulbs and add it up with this unit. So here, number of units is equal to what? 1 plus, there are 240 watt bulbs used for 2 hours daily. So 240 watt bulbs used for 2 hours daily, and we need to divide that by 1000 so that you get the number of units. So here, if we do the calculation, 2 into 40 into 2, so that is going to be 160 divided by 1000. So 1 plus 160 divided by 1000. So that is going to be equal to 1 plus 0.16. 1.16 units. Is that okay, students? So, initially we calculated the number of units used by the electric motor in 1 day. So, that is 1 unit. Why? The power is 1000 watts. It's used for 1 hour daily. You need to divide by 1000 so that you get the answer in kilowatt hours. Then the total number of units used up in 1 day, 1 for the electric motor. Then there are 2 bulbs with a power of 40 watts. Each one is used for 2 hours daily. So, in order to convert that to kilowatts, you need to divide by 1000. So, 2 into 40, 80, 80 into 2, 160. So 1 plus 160 divided by 1000. If you divide 160 by 1000, you get the answer as 0.16. So the number of units is 1.16 units. Then, here we can see the third part of the question. Cost of 1 unit of electricity consumed is rupees 3. So there 1 unit is rupees 3. What should be the monthly electricity bill? So you all know if it is for a month, we consider it as a 30-day month. Now we have calculated the number of units for 1 day. First you need to calculate the number of units for 30 days. So here units used in a day is 1.16. So units used in a month is equal to 1.16 into 30. So here you can calculate it 0, 18, so 4, 3. So that is going to be equal to 34.80 units. 34.80 units. Then you need to calculate the monthly electricity bill. So there the monthly bill value is how much? There are 34.80 units into 1 unit cost rupees 3. So into 3. That is going to be equal to 0, 4, 14, 10. So it is going to be 104.40 rupees. Or you can also write it as 104 rupees and 40 cents. That is fine as long as you get this particular value. So if you want to write, you can write as 104 rupees and 40 cents. So here students, you all have to remember when we calculate the number of units used in 1 day, if they ask for a month, you have to multiply by 30. So 1.16 units into 30, you get the answer as 34.80 units. And thereafter, if you calculate the monthly bill, each unit cost rupees 3. So 34.80 units into 3, you get the answer as 104.40. So that is going to be 104 rupees and 40 cents. I am sure students, you are also able to do these types of calculations correctly. So with that, we'll move on to the next question. Extra question 24. What is the electricity consumption during a month if 5 light bulbs, each having a power of 100 watts, 5 light bulbs, 100 watts, and 5 light bulbs, each having a power of 60 watts, are used for 4 hours daily. Both are used for 4 hours daily. So you need to find the electricity consumption. To do that, electricity consumed, what do? We have 5 bulbs, 100 watts each into 4 hours divided by 1000 plus again 5 bulbs, 60 watt power each into 4 hours again divided by 1000, all together multiply by 30. Why is that? This is for one bulb, one type of bulb. 5 bulbs, 100 watts, 4 hours daily divided by 1000 to convert it to kilowatt hours. Then another 5 bulbs with 60 watt power, 4 hours daily. Here also 60 watt power, 4 hours daily divided by 1000. Now this is for 1 day, but we need to calculate for a month. So you multiply it by 30. Here if we write it again, 5 into 4, 20 into 100, 2000 divided by 1000 plus. Here you have 5 into 4 again 20, 20 into 60, 1200 divided by 1000 into 30. So if we calculate, here this is 2 plus 1.2 into 30, that is going to be kilowatt hours. So here 3.2 into 30 kilowatt hours. So if we multiply 96 kilowatt hours. 96 kilowatt hours. 3.2 into 30, 96 kilowatt hours. That is the amount of electric energy consumed. So if we go back to the question, you can see here electricity consumption during a month, 5 lights, each having a power of 100 watts, and 5 lights each having a power of 60 watts are used daily for 4 hours in a household. So electricity consumed 5 bulbs, 100 watts, 4 hours divided by 1000. 5 bulbs, 60 watts, 4 hours divided by 1000 into 30. You can calculate each one separately, add them together and then multiply by 30, or you can write everything together and calculate. Then here 5 into 100 into 4, 2000 divided by 1000, 5 into 60 into 4, 1200 divided by 1000, add them together and then you multiply by 30. So 2 plus 1.2 into 30, 3.2 into 30, 96 kilowatt hours. That is the number of units consumed for a month. Number of units consumed for a month. I am sure you all also can do similar calculations. So with that, students, I will move on to the next slide. Extra question 25. In the previous question, if the first 60 units are charged at a rate of rupees 6 per unit and the other units are charged rupees 8 per unit, how much will be the monthly electricity bill of the house? So you can remember, students, in the previous question, here you can see 96 kilowatt hours. So there the total number of units is 96 units. And out of these, the first 60 units, they charge at a rate of 6. And the rest of the units at the rate of rupees 8. So first 60 out of 96 units at the rate of 6. So total cost is how much? Now first 60 units at the rate of rupees 6 plus 96 minus 60, that is the rest of the units at the rate of rupees 8. So here into 8. First 60 at the rate of 6. So 60 into 6, 360 rupees. Plus, why do we need to subtract? Because the first 60 has been already charged at the rate of 6 rupees. The rest of the units are 36 units. So here 36 into 8. So again, if we write 360 plus 36 into 8, 6 into 8, 48, 4, 3 into 8, 24, so 28, 288. So the total bill is going to be 8, 14, 6, 648 rupees. So that is the cost of the electricity bill. In the previous question, if the first 60 units are charged at a rate of 6 per unit and the other units are charged rupees 8 per unit, how much will be the monthly electricity bill of the house? So 96 units, first 60, 6 rupees. The rest we have calculated 96 minus 60, that is 36. So total cost 60 into 6 plus 96 minus 60 into 8. So 360 plus 36 into 8. That is 360 plus 288 rupees, and that is equal to 648 rupees. So here of course we can put that. And to make it more clear, this is done together because this is the cost of the first 60 units, that is the cost of the rest of the unit. So rupees 648. If you want, you can write that also, rupees 648. That is the cost of the monthly electricity bill. Is that clear, student? So you need to calculate the number of units considering all the electrical appliances and then multiply for a month by 30, and then you can calculate the electricity bill if you are given the cost of the units. Is that clear to you all? So with that, I'll move on to the last question of this chapter. Extra question 26. In a household, 4 light bulbs with 100 watt power. It's easy if we write it like this. 4 bulbs with 100 watt power. Each are used for 5 hours daily. And that is for 25 days. 25 days. One electric iron with the power of 1000 watts. So, one electric iron, 1000 watts, is used for 30 minutes per day. 30 minutes, that you know is equal to 0.5 hours per day, because 30 divided by 60, always it's easier to have the time in hours per day for 8 days in a month. That is for 8 days in a month. Calculate the electric energy consumption of the household for 1 month in kilowatt hours. Now here you have to remember, students, we don't multiply by 30 because they have given us the number of days. Now these particular bulbs are used for 25 days and the iron is only used for 8 days. So you need to multiply by that number of days only, the respective number of days. So the electric energy consumption, and that also in kilowatt hours. So here is equal to 4 bulbs into 100 watts into 5 hours daily into 25. That has to be divided by 1000 so that you get the kilowatt hours. That plus we have an iron 1000 watts into 0.5 hours into 8 days, again divided by 1000. So you will get the answer in kilowatt hours. So that is equal to, if we simplify, 4 into 25, 100 into 100 into 5 divided by 1000. You can do the calculation and write the final answer, or you can go in steps, if whatever is easier for you all. So here of course I can simplify 1000 and 1000, 0.5 into 8. So this is going to be, if we simplify, so that is 50 plus 4. 0.5 into 8, 4. 5 into 8, 40, so it's 4. So totally it is going to be 54 kilowatt hours. That is the electric energy consumption. So here look at the question. 4 bulbs, 100 watts each, 5 hours per day, like that 25 days. 1 iron, 1000 watt iron, 30 minutes, that is equal to 0.5 hours, 8 days. So electric energy consumption, 4 into 100 into 5 into 25, you have to divide by 1000 to convert it to kilowatt hours. 1000 into 0.5 into 8 divided by 1000. Instead of this, you can even write 30 divided by 60 there. Whatever is convenient for you all. You can do the conversion here and substitute, or show the conversion there. but it has to be in hours. Time has to be in hours and kilowatt hours. So when you simplify, you get the answer as 54 kilowatt hour. So that is how you calculate the energy consumed, electric energy consumed by these devices in a month. So here the main thing is the difference from the previous calculation is that each device is used for different number of days in 1 month. So you have to use those number of days, not 30 days. Is that clear to you? So these are all different types of calculations that you need to understand. I am sure you all are able to answer these correctly. So with that, students, I am going to end this chapter, and for that matter, I am going to end this lesson. So far, we have discussed the components of the household circuit, the power, energy, and the commercial unit used to measure electricity, and also we discussed the different efficiencies of different types of electrical equipment. So I am sure you all have a very good understanding of this lesson.
To watch these important lessons, subscribe to DP Education's YouTube channel right now. Click on the bell icon to stay updated on the latest lessons. Sri Lanka's largest free online school, DP Education.